Good morning to all. I am Dr. Anna Pedushni, Professor and Dean of Research and Development Cell, Rohini College of Engineering and Technology. Today's class we shall discuss about the attitude and orbital control in satellite communication system. This attitude and orbital control is the main thing for the control of the satellite. So here the satellite communication is of two types, that is space segment and earth segment. So in space segment, it discuss about the satellite and its orbit. So attitude control is to maintain the satellite in its correct orbit in its correct position. First of all, attitude control. Attitude control refers to the orientation of satellite in space. So when we are launching the satellite, along with the payload, the needed equipment for its maintaining its correct position and its correct attitude is also carried by the satellites. So for which it consists of number of direction antennas as well as omnidirectional antennas, and also it consists of number of transponders and some communication devices as well as the thrusters to maintain the attitude of the satellites. So in case of environmental satellites, the sensing equipments must cover the X region. So we are using the infrared sensors. These infrared sensors will cover the entire Earth. So first of all, we can segment the active control of two types. One is active method and one is passive method. So in case of active method, some mechanisms are followed, and in case of passive method, some mechanisms are followed. So when the satellite is in position, when the satellite is rotating around the Earth, there are a number of disturbances forces that would make the satellite to alter its position. So there are a number of control signals will be sent from the Earth station to maintain the satellite in its correct position. So some of the causes of this attitude, change in attitude, are the gravitational force from the sun as well as Earth and as well as the moon, and also some solar radiation. To control this, first one is the active method. So in this active method, infrared sensors are placed, so that will cover the entire Earth. So the first one, the Earth region is divided into four quadrants, and we will place four sensors in four not to cover the four quadrants. So because of that, it detects the rim of the Earth against the space. So in case of any changes in its position, that will be identified, and from the control signals and from the Earth, the position of the satellite is identified. So next is the passive control mechanisms. In passive control mechanisms, we are giving some thrusters as well as jets that will be launched during the transmission while launching the satellites. Along with within the satellite, we will place thrusters and jets. So by activating these thrusters and jets, we can provide the attitude control. So here there are two types of passive control mechanisms are provided. First one is the spin stabilization. So the spinning stabilization that is used for cylindrical satellites. So it is used to mechanically balance both to on one particular axis, and then set the spin around the axis. So for geostation axis, this spin is adjusted in the north-south axis. So the spin rate is maintained to be of 50 to 100 revolution per minute. In case of any deviations in its spin rate, that will be noticed. So this is a cylindrical satellite which revolves around the Earth. So this is especially used for the geosynchronous satellites. So next type of stabilization is provided by momentum wheel stabilization. So this type of momentum wheel stabilization is used for the satellites with cubic structure. So based on the structure of the satellites, the stabilization mechanism is the BD. So next, the most commonly used is momentum wheel stabilization. So this is used for cube-like structures. So here it is mainly used in indoor satellites. So this momentable stabilization will consist of the flywheels, bearing assembly, casing, and an electrical drive motor associated with the electronic control circuitry. So here the flywheels which will be attached to the rotor, and it consists of a permanent magnet which provides magnetic field for motor action. The stator of the motor is attached to the body of the satellite. So thus the coupling between the flywheel and satellite structure is provided. So because of that, the speed and the torque of the motor is controlled by flow of the excess current flow through the stator. So this is the momentum wheel stabilization. There are three types of momentum wheel stabilization will be there. First one is the single wheel stabilization. For this stabilization purpose, we are using three axes. There is pitch, roll, and the yaw axis. So this maintains the stabilization of the wheels. So second one is the two wheel stabilization. This total stabilization is provided by using two wheels. One is used to control the pitch wheel, and another one is to control the yaw axis. The third one is the three-wheel stabilization. So in case of three-wheel stabilization, it uses three wheels to provide the stabilization. We have three wheels, one for yaw, one for pitch, and another one for roll axis. So these three wheels independently control the three axes. Because of that, the variations will be identified, and it produces the thrusters, and it makes the satellites to be rotating in exact positions.